The ear is a deceptively complex part of the human body, but absolutely fascinating when you learn about its intricacies. It contains the 3 smallest bones in the whole body, a beautiful solution to convert vibrations into recognizable noises, and an almost alien-like organ designed to recognize the position of your head and aid in balance. Let's start by looking at its main components. The ear can be divided into 3 parts: the external, middle, and inner ear. The external ear comprises everything you see from the outside, more properly known as the auricle or pinna, and the outermost part of the ear canal, again better known as the external acoustic meatus. The auricle is designed carefully to capture sound and transmit it towards the inner ear. It thus acts and subsequently looks a lot like a satellite dish. Most of the auricle is supported by cartilage, allowing it some strength whilst also being rather flexible. The outermost curved surface of the ear is known as the helix, which runs around most of the outer ear. Directly proximal to this, and running in much the same way, is the similar antihelix, which splits at its top into 2 more parts, the superior and inferior crura. Right in the middle of the pinna, and directly before the beginning of the external acoustic meatus, is a shallow depression known as the concha. This helps to direct vibrations inwards towards the tympanic membrane. The concha and its surrounding structures look a bit like a seashell, hence its name, which derives from the Latin word for shell. The last part of the auricle to note is the small cartilaginous projection near the concha known as the tragus. The second part of the external ear, the external acoustic meatus, is a fairly simple hollow tunnel running horizontally and slightly S-shaped into the head. Its outermost third is walled by cartilage, whilst the inner 2/3 are surrounded by the temporal bone on all sides. This is approximately what the shape of the external acoustic meatus looks like from above. At the end of the external acoustic meatus is the tympanic membrane, which is the first part of the ear to directly vibrate with the incoming sound waves. The tympanic membrane is the border between the external and middle ear. This is the view of the right tympanic membrane you'll get through an otoscope in a healthy individual. Looking at the tympanic membrane from the outside, it's covered by a very thin layer of skin, but is mostly translucent. Its translucency allows us to see some of the structures of the middle ear through it when shining a bright light. The most apparent of these structures is part of one of the middle ear bones, the malleus. We can see the impression of the lateral process, the handle, and the umbo of the malleus. The umbo gets its name from the Latin word for a shield boss, which is a round projection on the front of a soldier's shield. Everything below the lateral process of the malleus is known as the pars tensor, and everything above it, the pars flaccida. Surrounding the tympanic membrane is a fibrocartilaginous ring that anchors it in place. Worth noting is that the internal surface of the tympanic membrane is crossed by the chorda tympani branch of the facial nerve. Now let's look closer at the middle ear. The middle ear sits entirely within the tympanic bone in a hollow cavity that allows the bones to vibrate freely. The main part of this cavity is known simply as the tympanic cavity, whilst the uppermost part is known as the epitympanic recess. The epitympanic recess is important clinically as it's a communication with the mastoid air cells in the tympanic bone via the superior mastoid antrum. Infection can easily track upwards from the middle ear to involve the mastoid air cells and cause serious complications, potentially continuing upwards to involve the dura and brain. The 3 bones of the middle ear are the auditory ossicles, and they join together in a line to transmit vibrations from the tympanic membrane to the oval window of the vestibule. These bones are named the malleus, incus, and stapes respectively. We've already covered a bit of the malleus, but here it is from a different perspective. We see the handle, which is the part in contact with the tympanic membrane, the anterior process, the neck, and the head. The head sits in the epitympanic recess and articulates with the incus. The incus is relatively simple and consists only of a body and a short and long process. The body articulates with the malleus, and the long process articulates with the stapes. The last ossicle, the stapes, is strangely shaped just like a stirrup. It has a central hole bordered on either side by the anterior and posterior crura. It has a head which articulates with the incus, and a footplate that joins the oval window of the vestibular apparatus. In the inferior part of the middle ear, there's a bony cartilaginous tube that travels inferomedially to connect with the back of the nasopharynx. This is known as the eustachian tube and serves the clever function of equalising air pressure between the middle ear and the outside world via your mouth. It's the reason you can pop your ears on an aeroplane as pressure changes. The last two things to note in the middle ear are a pair of tiny muscles. The first is the tensor tympani, which goes from the eustachian tube to the malleus and is innervated by the mandibular nerve. The second is the stapedius, which connects to the stapes and is innervated by the facial nerve. They contract in the acoustic reflex to tense their respective structures and protect the inner ear from loud noises. Lastly, we have the fascinating inner ear. This contains the cochlea that is involved in converting vibrations into recognisable sounds, the vestibular apparatus, and the semicircular canals, which sense the position of the head and assist in balance. We'll just cover the key features of these structures today, as they warrant their own session at a later date. The inner ear can be divided into a bony labyrinth, which is basically the main structures we can see here, and the membranous labyrinth, which is a series of ducts that contain endolymph fluid and sit within the bony labyrinth. The cochlea is a spiral-shaped structure that looks a bit like a snail's shell. It's the part of the ear that converts vibrations into noise signals that can be sent to the brain. It communicates with the middle ear via the round window, which we'll talk about more in a later session. The central part of the cochlea is attached to a ridge of bone known as the modiolus, which is what it wraps around to produce its recognisable shape. The vestibule is the middle portion of the bony labyrinth and sits in contact with the footplate of the stapes bone, connecting via the oval window. Finally, the three semicircular canals are the structures largely responsible for our sense of balance. They are C-shaped projections that come out of the vestibule at 90 degrees to one another. Fluid is allowed to flow around these canals, and its direction of movement is used to determine what direction the head is moving and thus determine the body's position in space. At the base of each semicircular canal is a swelling known as an ampulla. The last structure to note in the inner ear is the vestibulocochlear nerve, which enters the inner ear via the internal acoustic meatus. It divides into two individual nerves, one to the cochlea and one to the vestibule, hence its name. The facial nerve also passes through the inner ear, but it has no innervation here. And there we go, that's a whistle-stop tour of the external, middle and inner ear. I hope you found this session useful, and remember to subscribe so you don't miss upcoming tutorials that will delve deeper into the details of the inner ear as well as the cranial nerves and their functions. Have a great day.